Okay, let's do classwork 9. Small introduction. We are going to solve inequalities now. So we're still graphing systems and they will cross, but that's not going to be the solution. We're going to have an infinite amount of solutions. Let me just show you. We're still using b for number 1, the first equation, as -1. So this is still in the b spot. So we do plot -1 on the y. And then we come here and plot m 2 over 1. Remember, put that over 1. And you're going to do that from -1 on the y-axis. So here's -1, go up 2 and over 1. Now we continue that pattern to finish graphing the line. Do the opposite. Do the opposite. Now, before you run and jump and start connecting the line, we have to talk about what this means. There are two things you need to understand about. That is what we call an inequality sign. So let's just talk about that. Inequality signs tell you these two things. Where to shade, and I probably should have said the other one first, but oh well. Where to shade, and then it also tells you how to connect the line. The reason I said I should have started with this one is because the next thing we're going to do is connect the line. So we have to know how to connect the line. You will either draw some people call it dotted line, some people call it dashed. You can call it whatever makes sense to you. So you must draw a dotted or dashed line, and then if it's not dotted or dashed, it is going to be solid. So when do you do that? Well, it's dotted when there is no line under it, and I will get into the reason later. So if you notice, this is less than, this is greater than. There is no line under it. That line under it is an equal sign. So look at the difference between the two. This one has a line under it. This one does not. It will be solid when the line is there, when the equal is there. And that's for less than or greater than. So that's for my less than or my greater than. And for those that are having trouble remembering which is which, here is a little trick. If you draw both of them and then try to spell the word less with it, whichever one makes sense and looks like the word less, that's your less than sign. And so that, I don't think we spell less that way. So that means this is your less than sign, the other one would be greater. Okay, so now that we understand the one without the equal signs need to be dotted or dashed, and the ones that are solid have the equal sign, let's look back at equation number 1. Do we have a line under it, yes or no? No, we do not. So that means it will not be solid. We must draw a dotted or dashed line. So I'm going to take my straight edge that my lovely assistant gave me, and I am going to connect it, but I'm going to dash it. And as you, excuse me, and as you can see, it's dashed. I have little holes in my when I connected it. Put my arrows. Okay. So now, I need to shade. I need to shade. How do you know which way to shade? If it says less than or equal to. If it's less than, period, you will shade below. That's a greater than sign. I just realized that. Sorry. So let me move it down here. You will shade below. Okay? If it's greater than, you will shade above. Sorry guys about that. I guess it's good to see the teacher make mistakes. Okay, so less than means to shade below. How do I know this is less than? LESS. Less than means to shade below. Greater than means to shade above. Okay, so now let's go to the line and let's understand what below and above means. If you lay your pencil down, which way does it need to roll in order to be below? Well, that would be that way, down. So maybe we can make a note over here, shade down, and then for above we can write shade up, because when I lay my pencil down and I say go up, what are we going to do? Move the pencil up. So now we look back at this problem, and what does it say? Less than. That means to shade down. So you're going to lightly take your pencil or pen, hopefully you have a pencil, and lightly shade down. And now we look here and we see that we got it right. Okay, let's move to the next one, because we have to do both equations on the same graph. So we still plot 5, which is our B, and it's positive 5, so we're up 5. And our slope is negative 1. So we are going to go down 1, but right 1. So down 1, right 1, down 1, right 1, down 1, right 1. Now you notice how I have to actually do this on top of the shading? Yeah, so I'm going to continue that on top of the shading. Okay, and now I'm going to go the other way. Okay, and then we're going to connect that. But before we connect it, because we're so used to just drawing a solid line, let's go back and check and make sure that we connect it the right way. So you kind of have to take your time, because we have built a lot of muscle memory, and we're so used to connecting. We got to remember today, there's a special way you connect it on some of the problems. So let's slow down. I know you're excited because you understand it. Right here it says for the second equation, greater than or equal to. So let's check how to connect the line. Greater than or equal to says solid. So we can go ahead and connect it with a solid line. And if you notice, I put my arrows and there are no holes. Now we need to shade, and because it says greater than, I put my pencil. Which way do we shade? Down or up? I'm going to shade up. Which way is up? That way. So lightly shade. Okay, let's look at the next graph and make sure we shade it correctly. Here it went up. Great. So they match. Now we ask ourselves, what is the solution? A lot of you are probably saying, there he is right there. Okay, let's understand what the solutions are for this problem, because there's more than one. Let's start off with the easy part. The double shaded region is the solution area. So let's look here, and it's always going to be between two lines. So let's look here. Do you see shading from one direction and then shading from another direction in this area? It's not double shaded, it's only shaded once, so this is not the solution area. Let's try here. Is this the solution area? It's between two lines. No, it's not, because it is not, there's no shading there at all. Let's try this one down here. I see shading, but I only see shading once. Let's try here. We see the shaded region, the double shaded region here. I'm gonna highlight it. And everything you see highlighted would be considered the solution. And actually it keeps going because of the arrow. keeps going. So I can highlight all of that. Everything that falls in that area would be considered a solution. All of this and more. I could color the desk, but I don't want to mess it up. That's the solution area and more. Okay? So when they ask for the solution, you don't have just one. Let's name some solutions in that area. Okay, let's see here. This is 1, 2, 3, 4, 5, 6. So 6-1 would be a solution. Use my red pen. 6-1 would be a solution. 5-2 would be a solution. 5, let's see, 4-3 would be a solution. All of those are in the shaded, double shaded region. Okay? Let's talk about the solutions or the points on the lines. Okay, now I know this is a lot of information, so let's take it slowly. And I'm going to move down here to this picture. Okay? If the solution is on the side, if the point is on the solid line, it's a solution. So this is a solution. This is a solution. This is a solution. This is a solution. And the solution's in the shaded, double shaded region. So all of my red points are solutions. Now we check the dotted line. This here, on the dotted dashed line, and we're using my pencil, they are not solutions. So the pencil points are not solutions. Now, we need to discuss why. What is important to know about the solution set for this problem? A couple of things we need to write down. And after we finish this, guys, that's the lesson. I've told you everything. The only other thing we're going to do outside of this is solve for y and then graph it. So we're good. I mean, this is the whole lesson. Let's write down what we have learned. Let's reflect. You're still graphing systems, so they will cross, okay? But what's important about the solution set? Okay, the solution set is the double shaded region. Okay, there is not just one solution anymore. How many solutions are there? There are infinite amount of solutions. That means so many you can't count. There are infinite amount of solutions. Okay. Okay. When is it a solution? Points are solutions when what? Okay. In the double shaded region. Double shaded region. Should you be writing this down? Yes. So let me give you a moment to catch up. And I'll just wait. The solution set, double shaded region. There is not just one solution. There are an infinite amount of solutions. The points that are solutions would be the points in the double shaded region. Points are solutions. When dot, dot, dot. The points are in the double shaded region. What else? When else are the points the solutions? When they are on a solid line. Okay. Dun, 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 dun. Okay. Let's talk about when they're not solutions. Points are not solutions. When what? When dun dun dun. Okay, they're not solutions when they are on the dash. Some want to say dotted. Some want to say the line with the spaces in it. When they're on the dashed or solid line, what else can we say? Let's keep going. I'm waiting. I was thinking somebody would give it to me out loud, but everybody's just sitting there watching the video. Let's see. It's when it's not in the double shaded area. So not double shaded, not double shaded, not double shaded. Actually, these aren't shaded at all on this paper, on this picture. But if we go up here, remember the shading was there and there and there, but these didn't count because it wasn't double shaded. So points that are not solutions, that happens when they're not in the shade, the double shaded area. Okay. Now I could take you a step further and we could plug in some points and see how it works, but I think that's enough for this stop. So I'm going to stop this video, let you take a little breather, and then we're going to go to the next one. Good job, you guys.